Trigonometric functions. The main trigonometric ratios are sin theta, cos theta, tan theta, cosec theta, sec theta and cot theta. Trigonometric ratios are mainly defined on a right triangle. Consider a right triangle ABC. I am taking an acute angle theta. Then I can define the 6 trigonometric ratios as sin theta equals opposite side by hypotenuse. Sin theta equals opposite side by hypotenuse. Then cos theta equals adjacent side by hypotenuse. Then tan theta equals opposite side by adjacent sides. Then the remaining 3 ratios, cosec theta is the reciprocal of sin theta, that is hypotenuse by opposite sides. Then sec theta equals hypotenuse by adjacent sides. Then finally cot theta equals the reciprocal of tan theta, that is adjacent side by opposite sides. These are the 6 trigonometric ratios. Next, nature of trigonometric ratios. We have 4 quadrants. First quadrant, all the trigonometric ratios are positive. That is sin theta, cos theta, tan theta, cosec theta, sec theta, cot theta, all are positive. And in second quadrant, only sin and reciprocal is positive. That is sin theta and cosec theta are positive. And in third quadrant, tan theta and its reciprocal cot theta are positive, all others are negative. And in fourth quadrant, cos theta and its reciprocal sec theta are positive, all others are negative. Next is some results. I told you sin theta and cosec theta are reciprocals, so their product sin theta into cosec theta equals 1. Similarly, cos theta into sec theta equals 1. Also, tan theta into cot theta equals 1. In other words, cosec theta equals 1 by sin theta, or sin theta equals 1 by cosec theta. Sec theta equals 1 by cos theta, or cos theta equals 1 by sec theta. Similarly, cot theta equals 1 by tan theta, or tan theta equals 1 by cot theta. Next we have some identities. Identities. First one, sin square theta plus cos square theta equals 1. This is the first identity. From this we get sin square theta equals 1 minus cos square theta, or cos square theta equals 1 minus sin square theta. Next identity is c square theta minus tan square theta equals 1. From this also I get 2 byproducts, c square theta equals 1 plus tan square theta, or tan square theta equals c square theta minus 1. One more identity is there, cos square theta equals 1 plus cot square theta. From this I get cot square theta equals cos square theta minus 1, or cos square theta equals 1 plus cot square theta, cot square theta equals cos square theta minus 1, or cos square theta minus cot square theta equals 1. These are the main trigonometric identities. Next, addition formulae. First one, sin A plus B equals sin A cos B plus cos A sin B. Next, cos A plus B equals cos A cos B minus sin A sin B. Next one, tan A plus B equals tan A plus tan B minus 1 minus tan A tan B. In the case of tan, we can write tan A plus B plus C equals tan A plus tan B plus tan C minus tan A tan B tan C all divided by 1 minus tan A tan B minus tan B tan C minus tan C tan A. Tan A plus B plus C equals tan A plus tan B plus tan C minus tan A tan B tan C all divided by 1 minus tan A tan B minus tan B tan C minus tan C tan A. Next, subtraction formula. First one, sin A minus B equals sin A cos B minus cos A sin B. Next, cos A minus B. Cos A minus B equals cos A cos B plus sin A sin B. Third one, tan A minus B. Tan A minus B equals tan A minus tan B divided by 1 plus tan A tan B. So these three are the subtraction formulae. Sin A minus B equals sin A cos B minus cos A sin B. Cos A minus B equals cos A cos B plus sin A sin B. Then finally tan A minus B equals tan A minus tan B by 1 plus tan A tan B. Next, product formulae. 2 sin A cos B equals sin A plus B plus sin A minus B. Then 2 cos A sin B equals sin A plus B minus sin A minus B. Then 2 cos A cos B. 2 cos A cos B equals cos A plus B plus cos A minus B. Then 2 sin A sin B. 2 sin A sin B equals cos A minus B minus cos A plus B. So these are product formulae. Some more results are there. Sin C plus sin D. Sin C plus sin D equals 2 sin C plus D by 2 cos C minus D by 2. Then sin C minus sin D. Sin C minus sin D equals 2 cos C plus D by 2 sin C minus D by 2. Third one, cos C plus cos D. Cos C plus cos D equals 2 cos C plus D by 2 cos C minus D by 2. Then finally, cos C minus cos D equals minus 2 sin C plus D by 2 sin C minus D by 2. Next, multiple angles. First one, sin 2 theta equals 2 sin theta cos theta. Also it has other value in terms of tan theta. 2 tan theta divided by 1 plus tan square theta. Next, cos 2 theta. Cos 2 theta has 3 values. Cos square theta minus sin square theta, or 2 cos square theta minus 1, or 1 minus 2 sin square theta. It has also in terms of tan theta equals 1 minus tan square theta by 1 plus tan square theta. Next one, tan 2 theta. Tan 2 theta equals 2 tan theta divided by 1 minus tan square theta. These are multiple angles in terms of 2 theta. Also we have multiple angles in terms of 3 theta. Sin 3 theta equals 3 sin theta minus 4 sin cube theta. From this we get sin cube theta equals 1 by 4 into 3 sin theta minus sin 3 theta. Next one, cos 3 theta. Cos 3 theta equals 4 cos cube theta minus 3 cos theta. From here also we get cos cube theta equals 1 by 4 into 3 cos theta plus cos 3 theta. Also we have tan 3 theta equals 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. These are the multiple angles in terms of 3 theta. Next, sub multiple angles. Sin theta equals 2 sin theta by 2 cos theta by 2. Cos theta equals cos square theta by 2 minus sin square theta by 2, or 2 cos square theta by 2 minus 1, or 1 minus 2 sin square theta by 2. These are the main sub multiple angles. Next, trigonometric ratios of various angles. I first write the values of theta: 0, pi by 6 or 30, pi by 4 or 45, pi by 3 or 60, pi by 2 or 90, pi 180, 3 pi by 2 270, 2 pi 360. I am writing the values of sin theta, cos theta and tan theta of the various angles. Sin 0, 0, sin 30, 1 by 2, sin 45, 1 by root 2, sin 60, root 3 by 2, sin 90, 1, then sin 180, 0, sin 270 minus 1, and finally sin 360 equals 1, sin 360, 0. Then about cos theta, cos 0, 1, cos 30, root 3 by 2, cos 45, 1 by root 2, cos 60, 1 by 2, cos 90, 0, cos 180 minus 1, cos 270, 0, and cos 360, 1. Then about tan theta, tan 0, 0, tan 30, 1 by root 3, tan 45, 1, tan 60, root 3, tan 90 is not defined or infinity, tan 180, 0, tan 270 also not defined or infinity, tan 360, 0. In the other ratios, cosec theta, as I told you, the reciprocals of sin theta, sec theta, the reciprocal of cos theta, and finally cot theta, the reciprocal of tan theta. Now we can do some problems. We have studied the identities, results, etc. First one, if cos theta equals minus half and theta lies in third quadrant, find all other trigonometric ratios. Cos theta equals minus half, theta lies in third quadrant. We have to find the other 5 trigonometric ratios. For easy method, I can draw a right triangle ABC. Then I am taking the acute angle theta here. As I told you, sin theta equals opposite side by hypotenuse, but cos theta is given. Cos theta means adjacent side by hypotenuse. So first I have to find this opposite side. Using Pythagoras theorem, it is root of 2 square minus 1 equals root 3. So sin theta equals opposite side by adjacent side, but theta lies in third quadrant. In third quadrant only tan and its reciprocal cot theta are positive. All others are negative. So sin theta equals minus root 3 by 2. Cos theta is given. Tan theta equals opposite side by adjacent side. So root 3 by 1. Third quadrant tan is positive. Then cosec theta is the reciprocal of sin theta, minus 2 by root 3. Sec theta equals the reciprocal of cos theta, so minus 2. Cot theta is positive because theta lies in third quadrant. Reciprocal of tan theta 1 by root 3. Next one, cot x equals 3 by 4. X lies in third quadrant. As in the previous problem, here also I am drawing a right triangle ABC. I am taking here the angle x, acute angle x. Then what is cot x? Cot x means adjacent side by opposite side. So 3 by 4. Here also using Pythagorean theorem, finding the hypotenuse. Root of 3 square plus 4 square equal 5. Now I can easily find the remaining 5 ratios. Sin x equals opposite side by hypotenuse minus 4 by 5 because theta lies in or x lies in third quadrant. Cos x equals adjacent side by hypotenuse. Tan x equals the reciprocal of cot x. 4 by 3. It is positive because x lies in third quadrant. Then cosec x. Cosec x is the reciprocal of sin x. Minus 5 by 4. Sec x is the reciprocal of cos x. Minus 5 by 3. Cot x is given, that is 3 by 4. Next problem. Find sin 75, cos 75 and tan 75. Sin 75. Using the additional formula sin, I can write sin 75 as sin 45 plus 30. This is of the form sin A plus B. I told you sin A plus B equals sin A cos B plus cos A sin B. Here A stands for 45 and B equals 30 here. So sin 45 plus 30 equals sin 45 cos 30 plus cos 45 sin 30. I can replace the values. We have studied sin 45 1 by root 2, cos 30 root 3 by 2, cos 45 also 1 by root 2, sin 30 1 by 2. Now taking the LCM 2 root 2. So the answer is root 3 plus 1. That is sin 75 equals root 3 plus 1 all divided by 2 root 2. Similarly, we can find cos 75. 75 also can be split 45 plus 30. So cos 45 plus 30. Cos A plus B. We have studied cos A plus B equals cos A cos B minus sin A sin B. So cos 45 plus 30 equals cos 45 cos 30 minus sin 45 sin 30. So replace the values of cos 45, cos 30, sin 45 and sin 30. 1 by root 2, the root 3 by 2 minus 1 by root 2 into 1 by 2. Here also taking the LCM or simplifying. Root 3 minus 1 by 2 root 2. One more is there, tan 75. Tan 75 equals tan 45, tan of 45 plus 30. Here also using the formula tan A plus B. We have studied tan A plus B equals tan A plus tan B by 1 minus tan A tan B. So tan 45 plus 30 equals tan 45 plus tan 30 divided by 1 minus tan 45 tan 30. Here also replacing the values of tan 45 tan 30. So the answer is 1 plus 1 by root 3 divided by 1 minus 1 by root 3. Taking the LCM, root 3 plus 1 by root 3 divided by root 3 minus 1 by root 3. The answer is root 3 plus 1 by root 3 minus 1. Next, finds sin 15, cos 15 and tan 15. Here also we have to take the correct identities we have studied. Sin 15 can be written as sin 45 minus 30. This is of the form sin A minus B. We have studied sin A minus B equals sin A cos B minus cos A sin B. So sin 45 minus 30 equals sin 45 cos 30 minus cos 45 sin 30. Here also put the values of sin 45 and cos 30. The answer is 1 by root 2 into root 3 by 2 minus 1 by root 2 into 1 by 2. Here also taking the LCM. The answer is root 3 minus 1 by 2 root 2. This is the answer of sin 15. Similarly, we can find cos 15 and tan 15. Cos 15. Cos 15 also we can take cos 45 minus 30. Cos 45 minus 30. Cos of A minus B. Cos of A minus B equals cos A cos B plus sin A sin B. So, cos 45 cos 30 plus sin 45 sin 30. Here also replacing the values of cos 45 cos 30 sin 45 sin 30 equals 1 by root 2 root 3 by 2 plus 1 by root 2 into 1 by 2. Here also taking the LCM and simplifying, we get the answer root 3 plus 1 by 2 root 2. Next is tan 15. Tan 15 also I can write in the form tan A minus B. Tan 15 equals tan 45 minus 30. We have studied tan A minus B equals tan A minus tan B by 1 plus tan A tan B. So tan 45 minus 30 can be written in the form tan 45 minus tan 30 divided by 1 plus tan 45 into tan 30. Here also we are replacing the values of tan 45 and tan 30. Tan 45 equals 1. So 1 minus 1 by root 3 divided by 1 plus 1 by root 3. Taking the LCM and simplifying. The answer is root 3 minus 1 by root 3 divided by root 3 plus 1 by root 3. So simplifying, the answer is root 3 minus 1 by root 3 plus 1. Next, prove that tan 75 plus cos 75 equals 4. You have to find the values of tan 75 and cos 75 separately. Tan 75 equals tan 45 plus 30. Here also apply the value of tan A plus B. Tan A plus B equals tan A plus tan B by 1 minus tan A tan B equals tan 45 by tan 30 divided by 1 minus tan 45 tan 30. Replacing the values of tan 45 and tan 30. 1 plus 1 by root 3 divided by 1 minus 1 by root 3. Taking the LCM and simplifying. Root 3 plus 1 by root 3 by root 3 minus 1 by root 3. So the answer is root 3 plus 1 by root 3 minus 1. We know cot theta is a reciprocal of tan theta. So what is cot 75? Cot 75 is the reciprocal of root 3 plus 1 by root 3 minus 1. So it is root 3 minus 1 by root 3 plus 1. So adding the answers, tan 75 plus cot 75 equals root 3 plus 1 by root 3 minus 1 plus root 3 minus 1 by root 3 plus 1. Taking the LCM. The LCM is root 3 minus 1 into root 3 plus 1. Here we get root 3 plus 1 all square plus root 3 minus 1 all square. Simplifying using the identity a plus b all square and a minus b all square. We know a plus b all square equals a square plus 2ab plus b square and a minus b all square equals a square minus 2ab plus b square. So simplifying the results. We get a square plus 2ab plus b square, that is 3 plus 2 root 3 plus 1. Here a minus b all square, 3 minus 2 root 3 plus 1. Here a plus b into a minus b, a square minus b square, root 3 square minus 1 square, cancelling this. So I get 2 plus 1 4 plus 3 7 plus 1 8. 8 by 3 minus 1, that is 8 by 2 equals 4. So the result is proved. Tan 75 plus cot 75 equals 4. Next one, prove that cos pi by 4 minus x, cos pi by 4 minus y, minus sin pi by 4 minus x, sin pi by 4 minus y equals sin x plus y. We have to prove cos pi by 4 minus x, cos pi by 4 minus y, minus sin pi by 4 minus x, sin pi by 4 minus y equals sin x plus y. Such a problem, we have to apply the correct identity we have studied. Here this is of the form cos a cos b minus sin a sin b. We have studied cos a cos b minus sin a sin b equals cos a plus b. Here a stands for pi by 4 minus x and b stands for pi by 4 minus y. So this is of the form cos a plus b equals cos pi by 4 minus x plus pi by 4 minus y equals cos pi by 2 minus of x plus y. We know cos 90 minus theta equals sin theta or sin x plus y. So the result is proved. Next one, prove that tan pi by 4 plus x divided by tan pi by 4 minus x equals 1 plus tan x by 1 minus tan x all square. We have to prove that tan pi by 4 plus x by tan pi by 4 minus x equals 1 plus tan x by 1 minus tan x all square. Here also we have to apply the results we have studied. Tan a plus b divided by tan a minus b. So tan pi by 4 plus x divided by tan pi by 4 minus x equals, the numerator is of the form tan a plus b. We have studied that tan a plus b equals tan a plus tan b divided by 1 minus tan a tan b, and tan a minus b equals tan a minus tan b divided by 1 plus tan a tan b. So applying the results here, tan pi by 4 plus x equals tan pi by 4 plus tan x divided by 1 minus tan pi by 4 tan x all divided by tan pi by 4 minus tan x divided by 1 plus tan pi by 4 tan x. Tan pi by 4 we know 1. 1 plus tan x divided by 1 minus tan x all divided by 1 minus tan x by 1 plus tan x. So multiplying with reciprocals, I get 1 plus tan x by 1 minus tan x into 1 plus tan x by 1 minus tan x. So I get the result as 1 plus tan x by 1 minus tan x all square. This we needed. So the result is proved. Next, evaluate cos 9x minus cos 5x divided by sin 17x minus sin 3x. We have to find cos 9x minus cos 5x divided by sin 17x minus sin 3x. Here also we have to apply the results we have studied. We have to find cos 9x minus cos 5x divided by sin 17x minus sin 3x. Numerator is the form cos c minus cos d. Cos c minus cos d equals minus 2 sin c plus d by 2 sin c minus d by 2. And denominator is of the form sin c minus sin d. Sin c minus sin d equals 2 cos c plus d by 2 sin c minus d by 2. So applying the results here, minus 2 sin 9x plus 5x by 2 sin 9x minus 5x by 2, and denominator sin c minus sin d 2 cos 17x plus 3 by 2 and sin 17x minus 3x by 2. So the answer is minus sin 14x by 2, 7x. Here sin 2x divided by cos 10x, then sin 7x. So the answer is minus sin 2x divided by cos 10x. Next one, sin x plus sin 3x divided by cos x plus cos 3x. Here is also we have to apply the results we have studied. The numerator is the form sin c plus sin d and denominator is the form cos c plus cos d. We have studied sin c plus sin d equals 2 sin c plus d by 2 cos c minus d by 2, and cos c plus cos d equals 2 cos c plus d by 2 cos c minus d by 2. So applying the results here, 2 sin x plus 3x by 2 cos x minus 3x by 2 divided by 2 cos x plus 3x by 2 cos x minus 3x by 2. So the answer is sin 4x by 2 cos minus 2x by 2 divided by cos 4x by 2 cos minus 2x by 2. Here is the result, cos minus theta equals cos theta, because cos theta is an even function. So cancelling this, we get sin 2x by cos 2x. We have studied sin theta by cos theta equals tan theta. So the answer is tan 2x. Next, find the value of sin x minus sin y divided by cos x plus cos y. Here also we are applying the identity we have studied. Sin x minus sin y is of the form sin c minus sin d equals 2 cos x plus y by 2 sin x minus y by 2. Denominator is the form cos x plus cos y, that is cos c plus cos d. It is of the form 2 cos x plus y by 2 cos x minus y by 2. Cancelling this, we get tan x minus y by 2. Next one, prove that tan 4x equals 4 tan x into 1 minus tan square x all divided by 1 minus 6 tan square x plus tan raised to 4x. We have to prove that tan 4x equals 4 tan x into 1 minus tan square x by 1 minus 6 tan square x plus tan raised to 4x. So LHS is tan 4x. Tan 4x I can split tan 3x plus x. We have studied tan a plus b. Tan a plus b equals tan a plus tan b by 1 minus tan a tan b. So tan 3x plus x equals tan 3x plus tan x all divided by 1 minus tan 3x into tan x. Now I can replace the value of tan 3x. Tan 3x equals 3 tan x minus tan cube theta or tan cube x. Tan 3x plus tan x divided by 1 minus tan 3x tan x. We have studied tan 3x. 3 tan x minus tan cube x by 1 minus 3 tan square x plus tan x all divided by 1 minus, here also replace the value for tan 3x. 3 tan x minus tan cube x divided by 1 minus 3 tan square x into tan x. Here we have to take the LCM and simplifying 3 tan x minus tan cube x plus tan x into 1 minus 3 tan square x all divided by 1 minus 3 tan square x divided by, here also taking the LCM, 1 minus 3 tan square x, 1 minus 3 tan square x, removing the bracket, minus 3 tan square x plus tan raised to 4x. Simplifying equals 3 tan x minus tan cube x plus tan x minus 3 tan cube x divided by 1 minus 6 tan square x plus tan raised to 4x. The answer is 4 tan x minus 4 tan cube x divided by 1 minus 6 tan square x plus tan raised to 4x. Taking the common factor 4 tan x outside. 4 tan x into 1 minus tan square x divided by 1 minus 6 tan square x plus tan raised to 4x. This is the RHS. So it is verified. Next one, evaluate. Cos square pi by 3 plus sin square pi by 4 plus sin square pi by 6 plus cos square pi by 2. We have studied the trigonometric ratios over various angles. So, cos square pi by 3 plus sin square pi by 4 plus sin square pi by 6 plus cos square pi by 2. We have to substitute the values. We have studied cos 60 is 1 by 2. So cos square 60 is 1 by 2 square. Sin 45 1 by root 2. So it is 1 by root 2 square. Sin 30 1 by 2. So it is 1 by 2 square. And cos 90 0. So the answer is 1 by 4 plus 1 by 2 plus 1 by 4. The answer is 1. Next one, evaluate sin square pi by 6 plus cos square pi by 3 minus tan square pi by 4. Here also we want to find sin square pi by 6 plus cos square pi by 3 minus tan square pi by 4. We are also replacing the table values. Equals sin square 30 1 by 2 square, cos square 60 1 by 2 square, and tan 45 1. So 1 square again 1. So 1 by 4 plus 1 by 4 minus 1 equals 1 by 2 minus 1 equals minus 1 by 2. Next one, prove that cos 10, cos 50, cos 60, cos 70 equals root 3 by 16. Here also we want to apply the correct identifier we have studied. Prove that cos 10, cos 50, cos 60, cos 70 equals root 3 by 16. Here the LHS, cos 10, cos 50, cos 60, cos 70. Here we have to apply the identity we have studied. We know the value of cos 60. Cos 60 equals 1 by 2. And taking cos 10 and cos 50 together, we studied is the form 2 cos A cos B. So dividing and multiply with the number 2. Write the identity 2 cos A cos B. 2 cos A cos B we know cos A plus B plus cos A minus B into cos 70 cos 60 plus cos 40 cos minus theta equals cos theta into cos 70. Here also cos 60 1 by 2 plus cos 40 into cos 70. So multiplying 1 by 8 cos 70 plus 1 by 4 cos 40 cos 70 equals, here also dividing and multiplying with 2. Applying the result 2 cos A cos B, cos A plus B plus cos A minus B. So the answer is 1 by 8 cos 70 cos 110 plus cos 30 cos minus theta is cos theta 1 by 8 cos 70 plus 1 by 8 cos 110 plus 1 by 8 into cos 30 we know root 3 by 2. This is root 3 by 16 plus 1 by 2 cos 70. 1 by 8 cos 110 can be written as 1 by 2 cos 180 minus 70. Root 3 by 16. 1 by 8 cos 70. And 1 by 8 cos 180 minus theta is minus cos theta. So cancelling this. So we get the answer root 3 by 16. Next find sin x by 2 cos x by 2 tan x by 2, where tan x equals minus 4 by 3 and x lies in second quadrant. We have the result sin x by 2 equals root of 1 minus cos x by 2 and cos x by 2 equals root of 1 plus cos x by 2 and tan x by 2 equals sin x by 2 by cos x by 2. So also we are drawing a right triangle. We know tan x equals opposite side by adjacent side. So 4 by 3. This is using Pythagoras theorem. We get 5. Here we need cos x. It is in second quadrant. Second quadrant only sin is positive, cos is also negative. Cos x equals adjacent side by hypotenuse. So replacing the values of cos x here, root of 1 minus 3 by 5 by equals root of, taking the LCM, root of 8 by 10 or root of 4 by 5 or 2 by root 5. Here also substituting the value of cos x, 1 minus 3 by 5 divided by 2, taking the LCM, root of 1 by 5, then sin x by 2 by cos x by 2 equals 2 by root 5 divided by 1 by root 5 equals 2. Second problem, cos x equals minus 1 by 3 and x is in third quadrant. Here also we want to find sin x by 2, cos x by 2 and tan x by 2. Sin x by 2 we know root of 1 minus cos x by 2. Substituting the value of cos x here. Root of 1 minus 1 by 3 divided by 2. Root of 1 plus 1 by 3 by 2. Taking the LCM. So the answer is root of 4 by 6 equals root of 2 by 3 and cos x by 2. Root of 1 plus cos x by 2. You are also replacing the value of cos x. 1 minus 1 by 3 by 2. Simplifying. One by root 3. Then tan x by 2 equals sin x by 2 by cos x by 2. Sin x by 2 is root of 2 by 3 divided by 1 by root 3. So the answer is root 2. Next one, trigonometric equations. First one, if sin theta equals sin alpha, then theta equals n pi plus minus 1 raised to n into alpha, where n element of z. Second one, if cos theta equals cos alpha, implies theta equals 2n pi plus or minus alpha, n element of z. Third one, if tan theta equals tan alpha, implies theta equals n pi plus alpha, n element of z. These three are trigonometric equations. We can do some problems related to this. Find the general solution of the following. First one, tan x equals root 3. We have to find the general solution. Tan x equals root 3 means tan x equals tan 60 or tan x equals tan pi by 3. Here theta equals x and alpha equals pi by 3. We have studied tan theta equals tan alpha implies theta equals n pi plus alpha. So x equals n pi plus pi by 3, n element of z. Next one, sec x equals 2. Sec x equals 2 means cos x equals 1 by 2. 1 by 2 equals cos pi by 3. Cos x equals cos pi by 3. We have studied cos theta equals cos alpha implies theta equals 2n pi plus or minus alpha, or x equals 2n pi plus or minus pi by 3, n element of z. Third one, sin x equals 1 by 2. We also studied sin theta equals sin alpha implies theta equals n pi plus minus 1 raised to n alpha. So sin x equals sin 30 or sin pi by 6. So x equals n pi plus or minus minus 1 raised to n pi by 6, n element of z.